speak SQL, but well, there's a catch. The SQL Analytics Endpoint is read-only. Why this is the case and how the architecture is behind? Well, let's have a look. So let's have a look at the overall architecture. In general, in the Fabric periodic table, we see the SQL Analytics Endpoint with different scenarios, and you see it's tied to the Lakehouse. So when we draw it in our architecture board, we start off, of course, with OneDrive. OneDrive. And in this OneDrive, there is the Lakehouse. So, Lakehouse. This Lakehouse has two different folders. One folder is let's make it a little bit larger, the tables folder. And one folder is the files folder. There's a big difference. In the tables folder, only Delta format is accepted. In the files folder, you can basically do anything. Any format is accepted, right? On the tables folder, logically, then sits the Delta log. And the Delta log heads over to the metadata sync. The metadata sync is it's running in background, and with less than 1 minute lag. And this then heads over with the schema plus the metadata to the SQL Analytics Endpoint. Oh, that's not nice. SQL Analytics Endpoint. This is T-SQL and it's read-only. That's the main point here, right? So this is auto-generated. So when we have a look at the whole line, we see that from the tables folder, the data format, the data log is running the metadata sync and is leading to the auto-generated T-SQL Analytics Endpoint. Everything that you put in the files folder is not accessible in the T-SQL Analytics Endpoint. The analytics endpoint itself sits on top of the TDS endpoint, the SQL engine, SQL engine. The SQL engine is a distributed query engine, DQE. It's, by the way, identical to the warehouse, same engine. And the SQL engine, again, sits on top of the TDS protocol, which makes it standard compatible. It's a standard protocol, TDS endpoint. So it's compatible with SQL Server. From the TDS endpoint, you have a variety of endpoints where you can access this. This is the SQL Server Management Studio, of course, the Azure Data Studio, Power BI, JDBC or ODBC, and of course with the VS Code SQL extension. So these are all different endpoints, And it's a little bit like magic when you look at that. You start with the OneDrive, the tables folder, you go through the logs and metadata sync, and you end up in an auto-generated SQL Analytics Endpoint table that is accessible through everything. This is like the heart of everything, right? And this makes it so convenient that you can just throw in files and you can get out SQL Server. That's the magic. Dive a little bit into the SQL endpoint. To do that, we first need a Lakehouse. Oops, there's something I should resolve. Okay, so let's create a Lakehouse. It's pretty straightforward. Let's say worldwide importers Lakehouse. Create. And the next thing is that we will ingest some data into that Lakehouse. We will do it with an data flow gen 2. This is customer mention data. Okay, and next we will import that from a file. I will upload the file. So file is uploaded. Very straight. So let's create our table. This is dimension customer. So let's rename that. There we go, dimension customer. And we can, we have already the Lakehouse configured because we started it from the Lakehouse. So we can simply say save and run, and it will import the data. So our run is succeeded. You can see it here. So let's go back to our workspace. Let's have a look. Lakehouse refers the DBO schema. And we have the dimension customer in here. To work, we need some more data. But it's curring. So let's jump back to the workspace and let's create a pipeline. There we go. Ingest data from source to Lakehouse. So, and from there we can add a pipeline activity, and we will use a copy data activity. And when we click on it, we see the properties down here. This is the data copy to Lakehouse. And in the source field, we will connect by browsing all. We'll go to Azure Blobs. There we go. And there's an Azure Blob endpoint with sample data that we can use. There we go. Pretty straight. Okay, connection is done. And now we need to fill in the path, the sample data. Sample data, wide world importers data warehouse packet. Which is okay. So we need the binary format because we have Parquet. That looks really good. And let's switch to the destination, because there we want to import that in our Lakehouse, which we will find in the OneLake catalog, this Lakehouse. And we will put that in the files section. This is nice because I can show you then how to move files to tables. And the path is WWI raw data. File format is binary, so that looks really good. Let's save our pipeline and let's run our pipeline, and I will be back once the run has succeeded. Our run was successful, and now under the file tabs we have the Parquet files. And the next thing that we need to do is to import these Parquet files into our Lakehouse, so we can start playing around with the Lakehouse data. Okay, so we will do the import with a notebook. So let's go to our workspace. Oh, excuse me, my fault. Click Import, Notebook, and let's select the notebook from my computer. So let's have a more detailed look how the auto-sync data flow and metadata synchronization works. We start with the Spark Notebook, and from there we write the data in our Delta table. So let's say we do an insert or update or delete, you get it. This means that we get a new commit in the Delta log. The background scanner, which is here, background scanner runs continuously while the endpoint is active. So let's try it continuous. So this runs continuously. It polls for new commits, and we have a new commit here. So this new commit is detected. By the way, after 15 minutes of inactivity, this is paused, the scanner. So there's a 15-minute timeout. Then we have next the SQL Analytics Endpoint. The SQL Analytics Endpoint then gets an update from the metadata scanner, and this update updates metadata plus schema. Meta plus schema. When you are now a SQL client or any client which queries the SQL endpoint, you can do a select from table, select star from table, and you will get the latest data. When a new query arrives, so let's say this pause happened, then a new query arrives from the scanner, then you obviously wake up the scanner, and there is a resync from the metadata, resync, and once this resync happened, from the Delta log, the metadata is updated and the data is returned. So this is like the flow, right? And you see it's a continuous. So on the one side we have the Spark notebook, on the other side we have the SQL client, and in between there's a continuous scan, update, sleep, scan, update, sleep cycle. Yeah. The background polling, as we pointed out earlier, is less than 1 minute, and after 15 minutes of inactivity, there's a pause in the scanner because, well, to save compute capacities. So let's have a look at the security and access model. Who can do what? So security. So we have the layer 1. Layer 1 is workspace roles. So the roles you give in the workspace. There you have admin or member or contributor. They basically have full access on the SQL endpoint. They have full access. Then you have the viewer role. The viewer role has connect and read data. On the SQL endpoint. So full access means control. Then you have the layer 2. So this is layer 1. Then you have layer 2. Layer 2 is item sharing, when you share items, item level. So this is layer 2. There you can share with read data permission. When you do that, you have select on all tables. You can share with the read all permission. The read all permission means that you have direct file access. Not only select, you have access to the files. Next, you have SQL granular permissions. SQL granular permissions can be grant, revoke, deny, on the SQL endpoint. So everything that's pointed to the left is SQL endpoint. You have row level security on the SQL endpoint. You can have column level security on the SQL endpoint. You can have object level security on the SQL endpoint, and you can have dynamic data masking on the SQL endpoint. And of course, in these places, you define the appropriate permissions directly there. So there is no generic, because there is no generic role, also with grant, revoke, and deny. So this is the permission story on the SQL endpoint, and you see it's advanced. So I have selected the notebook, and the notebook import is in progress, and we can simply open the notebook, and we will see the content of that notebook. And when you have a look, it creates some data frames and then writes the data frames in the tables folder. So So that's the purpose for the fact table and for the dimensions. So it's a pretty straightforward, right? So let's run this story. Okay, so let's run our notebook. I've set the WWI Lakehouse as default Lakehouse. And so now everything should be nicely executable. So we run the fact sales table. Spark job is started. And you import the fact sales 1 year full and create our table with the table name fact sale. And then we can create the dimensions. And basically then we have built our Lakehouse here. Let's refresh. There might be already something. So not yet. I will return once everything is in there. Okay, now we have some tables in our Lakehouse. And we have the switcher on the top right between the Lakehouse view and the SQL Analytics Endpoint view, where we see our tables. Not all yet. Let's refresh. Yeah, there we go. Dimension city, for example, or the fact sales. And we can, for example, make a new SQL query by selecting the top 100. And it's executed and we see the results. We have also our SQL endpoint and the properties that we can copy, and then we can go, for example, to in the properties we have also our SQL endpoint that we can copy, and then we can go to, for example, Visual Studio Code and add a new connection and use that connection string to connect to our data. So this is how it looks like in VS Code. You see the tables here. The columns and keys and all that stuff. It's pretty straightforward, I think. We can even edit the tables. It's quite nice. We can create a new query. So I've copied the query that we have just created online. Let's run it here. So you see it's obviously the same result. When you connect with Power BI, you have the capability to go on the SQL endpoint, which is direct query, or you can go with direct lake directly to the OneLake. So let's have a look how this works in detail. So we start with our Power BI report. There we go. The Power BI report, let's say, goes to a semantic model, which is in the direct lake mode. Which means that it directly accesses the files on the OneLake. This is important. So then in general, it tries to access direct lake, directly. But there are certain conditions where this doesn't work. So the first question is, can direct lake serve this query? That's the main question here. There are some fallback triggers. Fallback triggers are SQL views, row level security, column level security, DEX over limits, internal limits, or exceeds memory. So, question is, can Direct Lake serve this query? If yes, pretty simple, we are on the fast path. Then, so Direct Lake reads the packet directly from OneLake, which is basically the idea. So this queries then the OneLake data packet files. So this is like the holy grail. This is the one that we want to get. So cool. We have a different story when, for whatever reason, there is a fallback. So it says no. Then we are in the fallback path. Fallback path means we have a direct query fallback. Direct query, not direct lake. Direct query fallback with the SQL Analytics Endpoint. That sits on the distributed SQL engine, SQL Server. So this in the end queries also the data packet files, but through the SQL engine, which is the fallback path. So Direct Lake is the default mode for semantic models on Lakehouse data. This is the fastest path, but there are direct query fallbacks. These are engaged automatically when the Direct Lake cannot serve the query. So when the query references a SQL view, when RLS or CLS is configured on the SQL endpoint, when the DAX query complexity or the data volume exceeds memory limits, or when the table uses calculated columns referring to a SQL endpoint. The fallback is transparent. The user doesn't see an error. It's just often slightly slower. You can monitor the fallbacks in the semantic model refresh history and in the Fabric capacity metrics app. And of course, best practices is to minimize these fallbacks. We have quite a few choices in Fabric, which usually is great. But let's create a decision matrix. So we have a user, respectively an application. We start with that. From there on, we have three different paths. The first one is we have select only. So we just want to run select something. With select something, we are in the area of read-only analytics. And read-only analytics means we go with our SQL Analytics Endpoint. It's auto-generated and read-only. Quite a few abbreviations here. SQL Analytics Endpoint on the Lakehouse. So it reads from Lakehouse, which equals delta table. So this is the read-only analytics story. Fairly simple. When we need read-write analytics, we are in the warehouse world. So then we need a warehouse with a full T-SQL DML. So then we say we need select, update, insert, delete. So everything, DML. So this then reads and writes, read and write to the warehouse storage. Which is also data tables, but it's hidden from your direct access. So this is read-only analytics. This is read-write analytics. And we have a third way. Oh, it's getting a little bit narrow here. The third way is we need OLTP transactions and full stored procedures. Full stored procedures. Then we are in the world of SQL Database, where we have the full SQL engine in Fabric still, if you want. And this, of course, then writes, there we go, reads and writes the SQL database storage, which is row store and column store, right? So there we are in the transactional world, OLTP. You can say, okay, but while we have also stored procedure support in warehouse, yes, we do, absolutely, but it's not full. So it's limited support. In SQL Server, you have, of course, full stored procedure support. Well, so this is like the decision matrix that we need to decide where to go. Let's go to the community question. Question number 1. 11 upvotes, 19 comments on Reddit. Why isn't SQL Analytics Endpoint supported by Git? So user created T-SQL views in the SQL Analytics Endpoint for an important import mode semantic model. When they enable the Git integration, SQL Analytics Endpoint items are not supported. No way to deploy views to production through source control. Community solutions. So first of all, T-SQL notebooks. So create notebooks with create or alter view statements, source control the notebooks, and execute them as a part of CI/CD pipelines. Second solution, warehouse for views. So create a dedicated warehouse just for views. Use 3-part names like lakehouse.dbo.table to reference the Lakehouse tables. Third solution, SQL Server Database Project. Use SSDT database projects with Synapse, serverless target type for schema management. Next question, how to identify that the SQL Analytics Endpoint is referencing the latest data? Problem is data pipelines write to Lakehouse and downstream warehouse views read the SQL endpoint. User needs to confirm that the metadata sync is complete before running dependent queries. Otherwise, queries return stale or missing data. Solutions. First, REST API for metadata refresh. Use the refresh SQL endpoint metadata REST API call. However, it takes minutes and it cannot be called in parallel for multiple tables. Control table pattern. Overwrite a 1-row control table in the Lakehouse with a timestamp. Query that table through the SQL endpoint to verify the freshness. And number 3 is, well, T-SQL system view, but there is no DMV or system view to check the sync status. Next question. Lakehouse SQL Endpoint ran. Problem is, there is some discussions in the community about syncing delays, metadata is not updated in a proper time frame, tables are disappearing from the SQL endpoint, inconsistent behavior. Why does it happen? Well, because in the end, everything relies on the background metadata sync process that scans the Delta transaction table, registers new Parquet files in with the SQL engine, and updates the metadata and the columns. This process is not instantaneous because it runs on a shared background service, and of course you have this less than 1 minute, but after 15 minutes of inactivity, the sync process goes cold and must restart. Each table is synced independently. A lakehouse with 100 tables takes longer than a lakehouse with only 10 tables. It can get even worse when you have too many small Parquet files, so when you don't run optimize, when you have too many lakehouses in a single workspace because of the resource contention, and when you have high cardinality partitions trading through thousands of partition folders. Well, again, delays in synchronizing the lakehouse with the SQL endpoint. So user reports 5 to 30 plus minute delays in metadata sync between lakehouse writes and SQL endpoint availability. Direct impact on production pipelines where downstream queries return incomplete data. Root cause is too many lakehouses per workspace, small Parquet files, high cardinality partitions, or cold start after inactivity. Problem: I cannot connect from my SQL Server Management Studio to the SQL Analytics Endpoint. Well, this can be related to the authentication model. So SQL Analytics Endpoint uses Microsoft Entra AD, formerly Azure AD, authentication only. SQL authentication is not supported by design. So you need to use version 20 or later and set the proper authentication to Microsoft Entra ID Universal with MFA and have a look at the proper connection string. Differences between connecting a semantic model to Lakehouse versus T-SQL Analytics Endpoint. Users are confused about whether to connect a Power BI semantic model to the Lakehouse directly or to the SQL Analytics Endpoint. Both appear as options and the different behavior is not obvious. So why does these two options exist? First, connection to the Lakehouse is the mode direct lake. It reads a Parquet file, it's a fast way, maximum performance, no SQL overhead. The SQL Analytics Endpoint is direct query, routes through the SQL engine. You have computed columns, you have views, you have row-level security, but it might be a little bit slower. Common pitfalls. We already mentioned the too many lakehouses in one workspace. So each lakehouse has its own SQL endpoint and all compete for the same sync resources. So when you have 10 to 20 lakehouses in a single workspace, this is too much. Limit it to a one-digit number. Pitfall number 2, do not running optimize on lakehouse tables, then you will get a bunch of Parquet files and performance will get worse. Run optimize after batch writes. Target is around 2 million records per Parquet file. Set max write per file during ingestion to prevent fragmentation. Using views in direct lake semantic models, you already heard that this triggers a fallback, a direct query fallback, which might not be intended. Adding foreign key constraints, so this prevents future schemas changes and creates maintenance headaches. When you add foreign key constraints in the SQL endpoint for documentation or semantic model relationships, these are informational only, but they block the schema evolution. So just use semantic model relationships instead of SQL foreign keys. Pro tips: first, use a warehouse as your SQL layer. Instead of creating views directly in the SQL Analytics Endpoint, create a dedicated warehouse for all your views, stored procedures, and cross-database queries. Use the 3-part naming. And use the REST API metadata refresh only for critical items in the pipeline. So in general, what the community loves is SQL access to Delta Lake without data duplication, familiar SQL, T-SQL syntax, automatic schema detection, and seamless integration with the Power BI Direct Lake mode. Thanks for attending this time. If you want to get a notify when I release a new video, just hit subscribe for this YouTube channel, and hope to see you next time. Thank you.